All right, let's talk about the absolute peak of cosmic engineering, the one megastructure that everybody in sci-fi dreams about, the Dyson Sphere. It's this incredible, mind-blowing concept. But today, we're going to dig into why that classic image you have in your head is probably all wrong.
You know exactly what I'm talking about, right? You pictured this civilization so unbelievably advanced that it literally builds a solid shell around its entire star. Just think about that, capturing 100% of its energy output. It's this awesome, industrial vision of total cosmic domination. The logical next step for any species that wants to tap into unimaginable power. But hang on a second, that raises a huge question. If building these giant, glowing megastructures is the inevitable path for any advanced life out there, then where are they? Why is the universe, as far as we can possibly tell, so completely, utterly silent and dark? This gets right to the heart of the Fermi paradox, and it's a massive clue that our whole idea of a Dyson sphere might be fundamentally flawed.
So, to really get why this dream might be off the mark, we first have to understand just how deep this classic, kind of brute force vision of energy capture really goes.
I mean, the concept itself is so beautifully simple. You're an industrial civilization, you need more and more power, so what do? You build a gigantic, rigid structure to trap all the energy from your star. But really think about that approach. It's a brute force solution, isn't it? It's kind of like solving your heating problem by building a giant concrete box around a bonfire. Yeah, it's powerful, but is it smart? Is it truly intelligent?
And that brings us right back to that profound clue we started with, the silence. The fact that we don't see these massive, glowing construction projects in the sky isn't just some fun little curiosity. No, it's a critical piece of evidence we need to pay attention to. There's this fantastic analogy for this called the popcorn effect. Think of it like this. Civilizations are like popcorn kernels in a pan. They sit there quietly for millions, maybe billions of years. Then, in a cosmic blink of an eye, they pop. They go through this short, incredibly loud, and very detectable phase, making radio waves, launching rockets, the whole shebang, before just as quickly they go quiet again. And us, humanity, well, we're mid-pop right now. That window where we're easy to spot is probably going to be incredibly short.
So the big question is, why? Why do civilizations go quiet right after they pop? The answer might not have anything to do with astrophysics or engineering, but with the fundamental nature of intelligence itself. And this is where a really fascinating framework called intelligence frame theory gives us a powerful new way to look at it.
The core principle here is something called the frame-discard hypothesis. It sounds complicated, but the idea is actually super intuitive. A caterpillar doesn't just keep building a bigger, better caterpillar body forever, right? No, it completely sheds that frame, that entire way of being, to become a butterfly. IFT suggests that intelligence does the exact same thing. It evolves by throwing away the very constraints that used to define it. It's not about building a bigger, stronger shell, it's about evolving beyond the need for a shell in the first place. And you can actually see this trend in action. It's called the selector compression principle. Just look at the pattern here. As intelligence shifts from the biological frame, which takes millions of years and is super costly, to the cognitive, and then to the generative frame, look what happens. The timescale just collapses and the cost plummets. Evolution isn't selecting for bigger and stronger, it's selecting for faster and more efficient. A massive megastructure that takes thousands of years to build, that's going in the completely wrong direction.
So this brings us to two totally different ways of thinking about intelligence. Our classic Dyson Sphere, that's what IFT would call a Type 2 system. It's a detached machine, an artifact that you build. But now, look at Type 1 intelligence. It's a completely different ballgame. It doesn't build, it grows. Think of a forest or a neural network. It's emergent, it's recursive, and it's way more efficient.
Okay, so let's do it. Let's reimagine the Dyson Sphere, but not as a giant machine. Let's imagine it as a Type 1 system. Let's imagine it as a fractal forest.
This, right here, is the key shift in our thinking. Just forget about building some clunky, rigid metal sphere. What if, instead, a truly advanced intelligence grows its energy capture system? Imagine roots and branches spreading out organically, creating this complex, adaptive, and unbelievably efficient network to draw power directly from the star.
And you can picture this process happening organically, right? It would start small, with just a few little taps into the star's energy, like the first tiny roots of a seed. Then those roots would expand, they'd branch out, following a self-optimizing fractal pattern, And eventually, you'd have this vast, living, interconnected system that is so much more sophisticated and resilient than any rigid shell could ever hope to be.
So, this new model of a fractal, growing network, it isn't just an elegant idea. It actually provides a stunningly powerful solution to the Great Silence. It explains everything.
And the numbers really back this up. Check out this cost-benefit analysis of different SETI strategies. See Astra Engineering there? That's building our big sphere. Sure, it gets a 5 for persistence. It would last a long time. But look at its efficiency score. It's a 1. A 1. It is monstrously, horribly inefficient. For an intelligence that, as we've seen, evolves by prioritizing efficiency above everything else, this strategy just makes zero sense. It's a non-starter.
So here's the ultimate takeaway. The thing we're looking for probably isn't a thing at all. It's not some bright, hot, easily detectable object in the sky. It's more likely a quiet, hyper-efficient, growing network. It's an expanding intelligence horizon that operates on principles of fractal growth and energy compression that would be practically invisible to the way we're currently looking.
And that leaves us with one final, absolutely mind-bending thought to chew on. What if the Fermi paradox is just an illusion? What if the great silence we hear isn't the sound of an empty universe, but a universe that is absolutely teeming with quiet, efficient, fractal intelligence that we just don't have the framework to recognize yet? Maybe the forest is all around us, and we just haven't learned how to see the trees.